Okay, now 34. So the last time I did um, a cubic question, where was it? Where did it come up? Oh, where was it? Where was it? Oh, there it is, 32. Only a couple of questions ago. Oh, the method I used was kind of advanced, kind of weird if you've not seen it before. And what I was going to do was just change the cost cubed into cost squared costs. And I should have stuck with that rather than introducing complex numbers. It's not appropriate for this particular book. So let's have a look at a more accessible way of doing this. First, let me just graph it. 2 cos 3x cubed and then y equals -1. Okay, and then pi over 4 to minus pi over 4. Okay, so yeah, interesting kind of shape going on here. I guess the good news is um, it's even, it's a symmetric function. So it would just be the integration from minus pi over 4 to pi over 4. The upper function, which is the 2 cos cubed 3x, minus the lower function, which is -1. So basically, I need to integrate. I just won't write the limits in again. 2 cos cubed 3x plus then that's dx plus then the integration of 1 dx with the limits. I will write them in. Pi over 4, pi over 4, minus pi over 4, and pi over 4. Well, this one here is pretty easy. That's just going to be pi over 2, because that becomes x. Pi over 4 minus pi over 4 is pi over 2. So it's pi over 2 plus 2. And then let's replace the cos cubed with cos 3x, cos squared 3x. And cos squared 3x is 1 minus sine squared 3x. That's kind of nice because what I can do is split this into cos 3x minus pi over 4 to pi over 4 dx, and then plus, or I guess minus, 2 times the integration of cos 3x sine squared 3x dx with the limits as well. Now I could use a substitution here. I could say let u equal sine 3x. And I'll put a 3 here and a 3 here. And just note, please, that the derivative would be 3 cos 3x. So in other words, du would be 3 cos 3x dx. I got sound, by the way. Yeah. So that means the 3 cos 3x dx, that's du. Oh, and this I can integrate. That's sine 3x over 3, pi over 4 minus pi over 4, and then that's minus 2 over 3 integration of u squared du. So let's see, that's pi over 2 plus 2. Now let me see what I get inside here. Sine 3 times pi over 4. Oh, yeah. Um, and then it's going to be 0, isn't it? Because it's odd. Uh, Sine is odd. Huh. Oh, not over 4. Sorry, I put the wrong number in. 3 times pi over 4. 3/4 pi. Sine 3/4 pi minus sine. Oh, but yeah, okay, no, never mind. I'm confusing myself. If I put those two values in and subtract, I'll get root 2. Okay, and then this would be minus 2/3 u cubed, which is sine cubed, u cubed over 3. That becomes u cubed over 3 with the limits minus pi over 4 and pi over 4. So that would be pi over 2 plus 2 root 2 minus 2 ninths if I want to take the 3 out. And then the cube then sine 3 over 4 pi cubed. Okay, I think that's, root 2 over 2. So they cancel out. 2 root 2 minus 1 over 9 root 2. So I'm getting 17 over 9 root 2 plus pi over 2 as the final answer. Let me check the answer because this is a bit tricky of a question. Hopefully I got this right. But I'm worried about my mental arithmetic, that I could have made a mistake somewhere. 2.35 roughly. Yeah, I've made a mistake somewhere possibly. Ah, let's check my mental arithmetic, huh? Go back a step now. Okay, 2 cos cubed 3x minus 1, that's plus 1. That integrates to x. Pi over 4 minus pi over 4, that's pi over 2. So I'm happy with that. That looks okay. And that's the 2. And I change cos cubed into cos squared. And cos squared is 1 minus sine squared. So that's 2 with the cos and 2 with the cos. This with the minus. Oh no, I do have the minus there. Okay, with the sine, and I put a 3 here and a 3 here, so that they become u, and that's u, So that one there becomes u cubed over 3, or 2/9 u cubed. Yeah, okay, so that's pi over 2. All right, and then let's see. Maybe I forgot to divide by 3, actually. I think that's probably it. 2.5. Yeah, maybe that's the issue. Let's see. And then this one here will be minus 2/3, or 2/9 sine cubed 3x minus pi over 4 to pi over 4. Okay. Yeah, that's quite small actually. So that's pi over 2 plus 2 root 2 over 3 minus root 2 over 18. Okay. 2.43 about. Roughly 2.4. So now I can check that answer again. What's that now? Hopefully I get something roughly 2.4. Then I think I have this correct now. Confirming. Uh, 2.3. Off ever so slightly. 2.3. Maybe maybe I didn't type the minus in correctly. Okay. Pi over 2 plus 2 over 3 root 2 minus root 2 over 18. Off such a small amount. Such a small amount. So I have a tiny, teeny, weeny mistake somewhere. Oh dear. Let me check that last one again. Sine 3x. No, that's root 2 over 18. Oh, I'm just off by 0.1. How frustrating is that? Frustrating is that? Maybe I can use my software to find where my mistake is to save time. Okay. So let's check now. Let's just check 1. Integrate minus pi over 4 to pi over 4. Huh? Oh, it doesn't like to integrate, just, yeah, pi over 2. Okay, so that's right. Okay. And then let's see what we get if we integrate cos cubed. Well, actually, what do I want? No, a cos 3x times 2. So that's this piece here, which is giving me that. Okay. 2 root 2 over 3. Okay, so that's correct. So that's right and that's right. So maybe it's the last one then, which is 2 cos and minus sine squared. So that's minus 2 cos 3x sine 3x squared. So just sine 3x again. 2 cos. Okay. Integrate minus 2 over root 9. Okay, so I'm missing a 2 somewhere. I divide by 2. So, okay. How am I losing a 2? I've just typed it in wrong. Let's check again. Sine. Yeah, I just typed it in wrong. That is a 9. So that is correct now. Just typing it in wrong on the calculator. That was it. Just calculator typing. Nothing more elaborate of an explanation than that. Okay, so that's the correct answer now. Double check it by typing in the value, pi over 2 plus 2 over 3 root 2 minus root 2 over 9. Yeah, 2.3. Okay.